Welcome back. In this video, we're going to talk about something that makes coding super powerful: loops. Loops help you repeat actions without writing the same code over and over again. We're going to learn specifically about for loops and while loops, and we'll stick with easy examples using only numbers and text. No fancy structures needed. Let's get started. What are loops? A loop tells Python, repeat this action until I say stop. Imagine clapping your hands 5 different times. If you're doing this in code, you might write a print statement that says, that you're clapping, and you would write this 5 different times. A loop allows you to only write this once, and the loop does all the heavy lifting, repeating this action 5 different times. The first loop we're going to talk about is going to be the for loop. Now, there's different types of loops when it comes to the for loop that we can use, but specifically, we're going to be talking about a for loop using a range method. The range method is a built-in method that comes with Python that allows you to select a range of numbers. Let's see some syntax. So first and foremost, to declare a loop in Python, we're going to use the for keyword. This for keyword tells Python that you're about to start a for loop. After the for keyword, you're going to follow it with a temporary variable or value. This value or variable could be called whatever you want. It's very common to see it written with I, which, if I'm correct, it tends to be referencing iteration. But it could be X, it could be A, it could be a word. Typically, you want to name this something that's relevant to what your for loop is iterating through. But what this temporary value or variable is used for is for us to have something as a reference to call the iteration that we are on. Now, this might seem a little confusing at first, but it'll make sense once we see it in action. So we'll say for I, which could be short for iteration, in the range of, so we'll say for I in range, and here's where we're using that built-in Python method of range. Now, this range method is pretty unique. Now, it does take multiple arguments, but only one of them is mandatory. That mandatory value or argument that you're going to pass in here is the range of what you want to go up to. For this scenario, we'll use 5. We'll say for I in range of 5. Now, this 5 specifies where we want to stop this range at. And that's all that we need here to declare the initial part of this for loop. When you're done declaring the for loop, you're going to end it with a colon. This colon specifies to Python that you're done declaring the initial part of the for loop and you're ready to add some logic. After the colon, if I press enter, you see here that by default, my code editor indents to the right. What this does, by adding the colon, it starts a code block. The code block, by default, is indented to specify where a code block starts and ends. The indentation is typically about 4 spaces. After the colon, everything that comes below this colon that's indented to the right belongs to the code block within this for loop. This is how Python is able to identify when the logic of a for loop stops and ends. And what I'm going to say here is I want to print out I, just so we can see what I is looking like and what's actually happening when this for loop runs. As you see here, when I press run, this for loop starts. And we see that we get 0, 1, 2, 3, 4 out in our output box, right? So this did run 5 different times, but you might be asking yourself, well, why didn't we get 5? And why did we start at 0? By default, very similar to how lists are ordered in 0 index, the range method works fairly similar. By default, it's going to start at 0. Even though that you put that the range you want to go to up to is 5, that stop point is up to but not including, so be aware of that. Now, you are able to manipulate this a little bit more to get a more specific range to get it actually go through 1 through 5, and we'll talk about that in a little bit. But as you can see here, as this for loop runs, that I is what we're printing out. That I changes values at every iteration. Once again, this is why we use this temporary value. This is supposed to represent the iteration that we are on, and it changes identity. So really, it's pointing out to a different value every single iteration. And we can use this to our advantage. Now let's talk a little bit more about this range method. As I told you, it does take multiple arguments. By default, it needs 1, which is a stop point. But it does take 3. The first one is the start, the middle one is the stop, and the last one in our third argument is the step. So let's go ahead and say start, stop, and step. By default, if you only add 1 value, that value is going to be your stop value. If you wanted to add a specific start point, then that would be before the stop. By default, it is preset that the start of the range method will start at 0. But you're able to override this. If I didn't want to start at 0 and I wanted to start at 1, like normal counting, I would say 1, 5. And now this specifies the start and the stop point of my range. Now let's see how that works. Let's run this. As you see here, I get 1, 2, 3, 4. So I was able to override the start point. I am starting at 1, but I'm still not getting that 5. Because once again, that stop point is up to, but not including. So if I wanted to ensure that I got that 5, all I would have to do is really just increase that number to go from 1 through 6. Because it's going to be up to, but not including 6, therefore giving me that 5. Now the last one here is the step. The step by default is actually set to 1. The step represents how many numbers are we supposed to go up or down during our iteration. Let's go ahead and change this stop point to 11 so we can get a little bit more numbers in here. And now we can see that when I override that default of step, instead of having it set to 1, let's go ahead and set this to 2. And I get 1, which is a start. I'm going up to 11, but I'm going to step over 2 numbers instead of 1. So I go from 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it will be 10 and 11, but it's up to but not including, so we don't see that 11. So the step represents how many numbers you want to increase or decrease throughout your iteration. Now I said decrease. What does that mean? Well, we're actually able to run backwards. What if the start point, instead of being 1, let's start at 5. And this time I want to stop at 0. And I want to go down in my numbers. So I add -1. And I see here, I go 5, 4, 3, 2, 1, up to, but not including the 0. So I do start at 5. It gives me my 5. I go up to, but not including my 0. And as I'm going to this for loop, I'm subtracting 1. And this could be very helpful if we did something like a countdown. We could say for I in range, I pass it 5, 0, -1. I can print out I. And what this is going to do is going to do my normal countdown that we see here, 5, 4, 3, 2, 1. And then once we're done with this for loop, all we have to do is unindent. And we can go back to the rest of our code like normal. Therefore, exiting this code block. And we can say print blast off. And there you have it. Now you have your typical countdown. The next item we're going to talk about is going to be our while loops. While loops are, just like our for loop, a form of a loop. What separates a for loop and a while loop is that a while loop typically uses a condition. The most common way of displaying how a while loop works is by using something like a counter. So what I'm going to do here is I'm going to create a counter. I'm going to set this at 1. Now, just like the for loop that requires the for keyword to be initialized, a while loop uses something similar. It's going to require a while keyword. Now, after the while keyword, you're going to specify the condition that's required for this while loop to run. And this condition is going to be while counter is less than or equal to 5. So it's a little bit different in syntax compared to the for loop. But what this while loop is going to do is it's going to run no matter what until that counter reaches something greater than 5. Because as we have it now, it's less than or equal to. So the logic, just like the for loop was, we add that colon to specify the start of our logic or our code block. And we can go to the next line and we can start adding the logic of our code. And we can say something like this, where we create a format string. And we say counter is at, let's go ahead and pass in the counter value in here. And I'm going to increase the counter by 1 as I do this. When I run this, I see here that the first time this runs, it's going to say counter is equal to 1. Awesome. We get to line 3. It's going to start this while loop. It reads while counter is less than or equal to 5. So it's going to check, is counter less than or equal to 5? Well, it is, because it's 1. So therefore, this condition checks out, very similar to an if or else block. So at that point, it goes into our code block at line 4. It's going to print out this formatted string or interpolated string. It's going to print out counter is at, and counter being set at 1 gives us this output of counter is at 1. And then the next line here is actually very important. This next line, we are increasing the value of counter by 1. Now, why do we do this? Well, as I mentioned earlier, the while loop is going to run as long as the condition is met. So what would happen if I didn't add this counter plus equals 1? Well, let's go ahead and remove this. And let's see if my code editor doesn't yell at me. But if I run this, I might not see anything right off the bat. And that's really more because my code editor is a little bit more specific. Doesn't really show you what's actually happened. But if I were to wait long enough here, I would get an error. We don't see it here, but under the hood, it's attempting to run this while loop, and it's running over and over again, but nothing actually else is happening. If you're using something like VS Code, you would see multiple different outputs here of the counter. And I don't know if you saw it real quickly here, it said it timed out. So although we didn't see it actually happening, what's really happening underneath the hood is